divided by omega n into square root of 1 minus theta square. So if you know the natural frequency, right, undamped natural frequency and the damping ratio, you can calculate this value of dp. That's the meaning. Understood? So now let us see the derivation for peak overshoot. Peak overshoot. The next one is the peak overshoot. Or MP or percentage MP we need to calculate, right? So here already you know the definition of this peak overshoot. Percentage MP is equal to C of TP minus C of infinity divided by C of infinity into 100. This is what the formula. So C of TP already you know the peak time, the response at peak time. This is known as C of TP. C of infinity means response at t equal to infinity. C of TP means response at t equal to peak time. Understood? So let us calculate these two values, C of TP and C of infinity, right? So for that also you have to consider the response of the second order system. Response of the second order system is C of t equal to 1 minus e power minus theta omega n into t divided by square root of 1 minus zeta square into sin omega d t plus theta. This is what the response of the second order system. So at t equal to infinity, right, when you substitute t equal to infinity here, what will be the answer? E power minus infinity. So e power minus infinity equal to 0. So 1 minus here also if you put t equal to 0, so you will get a sin 0. So this term equal to 0. Therefore at t equal to infinity, this C of t is equal to, or we can write C of infinity is equal to 1. Understood? Similarly, you need to calculate at t equal to Tp, what is C of t? That is C of Tp, right? So C of Tp is nothing but the response at time t equal to Tp. Understood? So which is equal to 1 minus e power minus theta omega n, instead of t you put Tp, right, divided by square root of 1 minus theta square into sin omega d Tp plus theta. Understood? So now this can be written as, which is equal to 1 minus e power minus theta omega n into Tp divided by 1 minus zeta square, square root of 1 minus theta square into sin omega d. Tp is nothing but already you have calculated the value of Tp in the previous derivation, that is pi by omega d, right, plus theta. Now this will becomes, which is equal to 1 minus, okay, which is equal to 1 minus e power minus theta omega n into, here also e power minus theta omega n into pi divided by omega n into square root of 1 minus theta square into sin, this can be cancelled out, sin pi plus theta, sin pi plus theta divided by square root of 1 minus theta square. Understood? Because your omega, just listen here, this t omega d, right? So already you have calculated this value of Tp equal to pi by omega d. So don't forget this. Just we have substituted this value here in this equation. This Tp equal to pi by omega d. Omega d is your omega n into square root of 1 minus theta square. That's all. So sin pi plus theta is coming. So sin pi plus theta is equal to minus sin theta, right? Therefore we can write this as Just listen. Therefore we can write this as, which is equal to 1 minus, right, e power minus theta pi divided by square root of 1 minus theta square whole divided by square root of 1 minus theta square. Understood? So this one is sin pi plus theta equal to minus sin theta. So therefore here you will get a minus sin theta. Understood? Therefore we can write this as, which is equal to 1 plus e power minus theta pi divided by square root of 1 minus theta square, the whole divided by square root of 1 minus theta square into sin theta you will get. Right? So instead of this sin theta, once again you can substitute from the right angle triangle, you can substitute square root of 1 minus theta square. So that we can write this equation as, which is equal to 1 plus e power minus theta pi divided by square root of 1 minus theta square whole divided by square root of 1 minus theta square into square root of 1 minus theta square. So we can cancel out these two things and we can write this as, which is equal to 1 plus e power minus theta pi divided by square root of 1 minus theta square. Right? So therefore now you are ready to calculate. This is C of Tp. Understood? You are ready to calculate the value of percentage MP. Percentage MP equal to, what is the formula? C of Tp minus C of infinity divided by C of infinity into 100. Okay. So now we can calculate this as, is equal to C of Tp is 1 plus e power minus theta pi divided by square root of 1 minus theta square minus C of infinity, already we have calculated it as 1 divided by 1, right? Or we can write this as, right? So we can write this as, which is equal to 1 plus e power minus theta pi divided by square root of 1 minus theta square minus 1 divided by 1 into 100. This is your percentage MP. So we can write this as, which is equal to e power, so 1 and 1 will get cancelled, e power minus theta pi divided by square root of 1 minus theta square into 100. So this is the formula to find percentage MP. Okay, so percentage MP equal to e power minus theta pi divided by square root of 1 minus theta square into 100, right? The final specification is your settling time, right? Final one, the fifth one is your settling time. What is settling time? The response of the second order system, already we have seen, it has two components. The first component is e power minus theta omega n into t divided by square root of 1 minus theta square. This is first component. Second component is sin omega dt plus theta. Understood? So in this, the decaying exponential term, this is known as decaying exponential term. So this dampens or reduces the oscillations produced by the sinusoidal components, right? So therefore the settling time is decided by the exponential component Tr. Okay, the settling time can be, we can find out the settling time by equating the exponential component to percentage tolerance error. How much percentage tolerance error you are specifying? For example, suppose if your specified percentage tolerance error is 2%, for 2% of tolerance error, your t equal to ts, the settling time ts equal to, that is e power minus theta omega n ts divided by square root of 1 minus theta square is equal to 0.02. So we are writing 2% as 0.02. So this term, this exponential term is equal to 0.02, right? For the least value of theta, for the least value of theta means we can remove this denominator. Understood? For this least value of theta, we can write it as e power minus theta omega n into Ts. We can write it as e power minus theta omega n into Ts is equal to 0.02. Suppose if you take the natural logarithm on both sides, you will get a theta omega n into Ts is equal to natural logarithm of 0.02. Understood? Or we can write it as minus, here minus sign is there, therefore minus theta omega n Ts is natural logarithm of 0.02. Therefore minus theta omega n into Ts is equal to minus 4. The value of natural log 0.02 is minus 4. Or we can write it Ts is equal to 4 divided by theta omega n. Here this value 1 by theta omega n is known as the time constant of the system. It is known as time constant of the system. Therefore we can write this settling time as Ts equal to 1 by 4 divided by theta omega n, which is equal to 4 times time constant. Understood? Similarly, suppose if you are specifying some other percentage of error, for example, for 5% error, this e power minus theta omega n into Ts is equal to 0.05. So in this case you will get a Ts equal to 3 divided by theta omega n. Understood? So in general we can write the settling time as settling time equal to natural logarithm of percentage of error divided by theta omega n. This is the formula to find the settling time of any system. Understood? So natural logarithm percentage error divided by theta omega n. Understood? Thank you.